Hello and welcome. My name is Jesus Ivan Flores Palacios, and in collaboration with my advisor, Dr. Sebastián Camargo Martinez, from the Faculty of Chemical Engineering at the Benemérita Universidad Autónoma de Puebla, I am pleased to present the following paper title: First Principles Assessment of Lattice Thermal Conductivity in the Aluminum Oxide and Gallium in Beta Pass, ALLOYS, for the International Material Research Congress 2026. Okay. In this poster presentation, we will cover 5 sections. In the first part, we begin with a brief introduction to beta pass gallium oxide, also known as monoclinic gallium oxide, which is an extremely promising ultra-wide bandgap semiconductor for next-generation power electronics. However, its practical application is limited by a relatively low and highly anisotropic bulk thermal conductivity. Allows this material with aluminum to form its structure system is an attractive strategy for bandgap engineering and heterostructures design. However, the effect of this substitution on phonon-mediated heat transport is not entirely clear. Therefore, our goal in this project is to evaluate how cationic composition and atomic ordering govern the thermal conductivity tensor, without assuming a priori that aluminum acts as thermal barrier or heatsink. Okay. Next, we will discuss the method used to perform this analysis, which consists of 3 fundamental stages. In the first stage, structural optimization with SIESTA completely relax the light vectors and atomic position of the structures using density functional theory calculation. For the second stage, network dynamics and stability with Phonopy, obtain the second order force constants to verify the dynamic stability of the crystal and calculate its vibrational state density. Finally, for the third stage, thermodynamics and transport with Phonopy, evaluate the thermodynamics functionals between 0 and 1000 Kelvin and obtain the third order and harmonic constants needed to calculate the thermal conductivity tensors. Continuing with the structure of the poster, we present the computational result we obtain at each stage mentioned in the computational methodology section. And we will cover 3 important points. Number 1, dynamic stability and cationic symmetry. The number 2, evolution of the phononic spectrum. And the number 3, thermal properties. Okay. And finally, we will discuss the analysis of the results and the promising findings regarding the alloying of aluminum with gallium oxide in the beta pass. It is worth noting that these calculations were made possible by the National Supercomputing Laboratory of Southwestern Mexico, which provided the computing results. Thank you for your attention and we'll see you at the conference. Goodbye.